Chapter 7. Preventive Controls. Determination for Human Food. David Rosson. Once hazards requiring a preventive control, significant hazards, are determined, preventive controls can be identified to help ensure the safety of the product. Keep in mind that while many different types of controls may be applied when processing a food, preventive controls are risk-based and focus on the significant hazards that present the greatest food safety risk to consumers. An overview of preventive controls is the focus of Chapter 7. By the end of this chapter, participants will be able to define preventive controls, explain preventive controls requirements and exceptions, describe examples of preventive controls, explain preventive controls considerations, describe e.g. food companies' preventive controls, describe preventive controls management components. That's important to remember. This definition. We covered earlier hazards evaluated and determined to be significant based on a hazard analysis for their severity and likelihood of occurrence will require a preventive control and must be addressed in the food safety plan. The term preventive controls is defined in the Preventive Controls for Human Food Regulation 21 CFR 1.1.7.3 as indicated in the slide. Note that the determination of a preventive control is risk-based, must be reasonably appropriate and consistent with the current scientific understanding. Keep in mind that preventive controls are subject to preventive control management components, i.e., monitoring, corrective actions and corrections, and verification, as appropriate to ensure the effectiveness of the preventive controls, taking into account the nature of the preventive control and its role in the facility's food safety system. To set the stage and to lay out what is required, check out this language directly from the regulation. 21 CFR 1.1.7.1 3 5A12 E to D and B. Preventive controls. The food safety team must identify and implement preventive controls to provide assurances that any hazards requiring a preventive control will be significantly minimized or prevented, and the food manufactured, processed, packed, or held by the facility will not be adulterated under Section 402 of the Federal Food, Drug, and Cosmetic Act, or misbranded under Section 403 W of the Federal Food, Drug, and Cosmetic Act. Preventive controls include 1. Controls at critical control points, CCPs, if there are any CCPs, and 2. Controls, other than those at CCPs, that are also appropriate for food safety, see 21 CFR 117.135A2. The preventive controls for human food regulation requirements specify that the preventive controls must be written, see 21 CFR 117.135B. The regulation requirements also specify that preventive controls must include, as appropriate to the facility and the food, 1. Process controls, 2. Food allergen controls, 3. Sanitation controls, 4. Supply chain controls, 5. Recall plan, and 6. Other controls. See 21 CFR 117.135C. Process preventive controls are discussed in Chapters 8, 9, and 10. Food allergen preventive controls are covered in Chapter 11. Sanitation preventive controls are discussed in Chapter 12. Supply chain preventive controls are discussed in Chapter 13. And recall plan is discussed in Chapter 15. In some cases, there may be other controls used by a facility as part of their food safety system, such as transportation controls, which would also be included here. This slide also shows direct language from the regulation 21 CFR 117.13 6A1-4, illustrating the circumstances when a manufacturer or processor is not required to implement a preventive control. 1. A preventive control is not required if the type of food cannot be consumed without the application of an appropriate control. 21 CFR 117.136A1. For example, a manufacturer processor of raw white rice or steel-cut oats could determine that the product will not be consumed without a cooking process that would adequately control vegetative pathogens that may be associated with the rice or oats. Other examples include raw agricultural commodities, such as cocoa beans, coffee beans, grains, which are cited in 21 CFR 117.136A 1.2. Another circumstance is when the manufacturer processor relies on their customer, commercial entity, not consumer, to control the identified hazard. For example, a manufacturer of untreated ground black pepper relies on its commercial customer to sterilize the black pepper, which the customer sells as a ready-to-eat product direct to consumers. The manufacturer processor of the untreated black pepper is not required to implement a preventive control for the hazard of pathogens associated with the black pepper if they comply with the disclosure requirements in 21 CFR 117.136A 2-4. The disclosure requirements require the manufacturer processor to disclose in documents accompanying the food, in accordance with the practice of the trade, that the food is not processed to control identified hazard. The disclosure requirement is in effect and enforceable by FDA. The customer written assurance, however, is under enforcement discretion, SEE, definition of enforcement discretion in Appendix 8. Note that this could change over time as the FDA adjusts its thinking, so it is particularly important that the preventive controls qualified individual keeps well informed of any potential regulatory developments. During the enforcement discretion period, the agency does not intend to enforce these provisions as they currently apply to certain entities or activities. In general, the FDA exercises enforcement discretion to allow time to consider changes or other approaches to address concerns regarding the application of these provisions to certain activities or entities. Preventive controls are not needed when the facility determines and documents that the type of food could not be consumed without processing that would control the hazard, e.g., grains such as raw white rice or steel-cut oats that require a cook step before consumption that would control vegetative pathogens. Some examples of preventive controls for biological, chemical, including radiological, and physical food safety hazards are listed in the slide above. For biological hazards, common control measures include those that 1. Significantly minimize or eliminate the pathogen, utilizing a lethality process control, such as thermal processing, high-pressure processing, irradiation, and 2. Prevent the germination of spores and or growth of microbial vegetative cells, such as time, temperature, process controls, refrigeration, freezing, or through product formulation process controls, such as water activity, acidification, preservation. Sanitation preventive controls may also be relevant to prevent recontamination of ready-to-eat products that are exposed to the environment before packaging. Supply chain programs may be relevant, especially if sensitive ingredients are used in ready-to-eat applications and involve verification of the supplier's controls used to control hazards in raw materials or other ingredients before receipt by a manufacturer processor. Preventive controls for chemical hazards include allergen controls for undeclared allergen hazards, sanitation controls for allergen cross-contact, supply chain programs that include testing for chemical hazards such as mycotoxins and pesticides. Physical hazards can be controlled by process controls, such as using equipment for straining or aspirating, mechanical separation, metal detection or X-ray, or other detection methods. For more examples and information about preventive controls, see the FDA Hazard Guide, Chapter 4. Preventive controls. Preventive controls for hazards introduced because of economically motivated adulteration may require a supply chain program or some of the methods above, depending on the specific hazard. The term sensitive ingredient is a term used by industry to refer to an ingredient with a history of association with a pathogen when controls are not in place. FSPCA. The food safety team must consider many factors when identifying preventive controls for the food safety hazards requiring them. In Chapter 2 of the FDA Hazard Guide, attached in the chapter Resources, FDA describes information related to the selection of preventive controls that the food safety team should consider. The effect of the control on identified potential food safety hazards, e.g., does the preventive control significantly minimize or prevent the potential food safety hazards identified? Is the preventive control hazard specific, or does it control more than one hazard? Does the control effectiveness depend upon other controls? Can the preventive control be validated and verified? The feasibility of monitoring those controls, i.e., are the critical limits, minimum or maximum values, and, if appropriate, operating limits for the preventive control measurable and practical? Can facility employees obtain the results of monitoring quickly, i.e., real time, to determine if the process is in control? Are employees monitoring a batch or continuous process? Is there a mechanism for monitoring continuously, or are employees doing spot checks? Can the parameters be monitored in line, or must the product be sampled? Will the monitored parameters be indirectly linked to the critical limit, i.e., belt speed or pump flow rate, for time of process? Who will perform the monitoring or checks, and what are the required qualifications? How is the monitoring verified? The location of the control with respect to other processing control measures, e.g., is the application of the control measure at the last point in the process to ensure control of the targeted potential food safety hazard? Will the failure of an upstream control result in failure of downstream controls, i.e., acidification failure, impacting thermal process efficacy for an acidified food? Are monitoring activities appropriate to ensure control at this step? Corrective actions that will be needed in the event of a failure of a control measure or a significant processing variability, e.g., can the process control and critical parameter be brought quickly back into control? How will employees determine if the control measure is, once again, under control? Can the implicated product be identified and its safety evaluated? Can the cause of the loss of control be identified and corrected? What actions would be needed to reduce the likelihood of the failure to recur? Can the product be reprocessed? What actions would be necessary to prevent unsafe product from entering commerce? Can product be diverted to animal food? Does the product need to be destroyed? The severity of the consequences in case of a failure of a control measure, e.g., is it reasonably likely that unsafe food would be produced as a result of the control measure failure? Is the hazard that could occur reasonably likely to cause serious adverse health consequences or death? Whether the control measure is applied to eliminate or significantly reduce the level of the hazard, e.g., will the control measure eliminate the hazard, or is the control measure only able to minimize the hazard? Synergistic effects between control measures, e.g., consider whether one control measure can enhance the efficacy of another control measure. For example, formulation process controls may combine the use of preservatives, acidification, and water activity at levels that individually will not control pathogen growth, but they work together to do so. The food safety team uses the written hazard analysis to design the approaches needed to control the hazards. The more thorough the hazard analysis, the more targeted the controls will be to ensure hazards are significantly minimized or prevented, and the more effective the food safety program will be in preventing illness or injury to consumers. At the completion of the hazard analysis, the food safety team documents the results of the hazard analysis process. The slide provides the model form with the items to be addressed. Other formats may be used as long as they clearly identify the potential hazards, evaluate the likelihood and severity of the risk, and identify preventive control measures that are used for all hazards that are reasonably likely to cause illness or injury in the absence of a preventive control. Column 5 is where the food safety team will identify preventive controls that will significantly minimize or prevent the identified food safety hazard you answered yes to in column 3. As illustrated in the shaded column 5, hazards requiring a preventive control must be managed through use of process preventive controls, allergen preventive controls, sanitation preventive controls, supply chain preventive controls, or other preventive controls as appropriate for the food and facility. Column 6. Because the worksheet breaks the production process into multiple steps, and the preventive control may be applied at a step in the process other than the step where the hazard was listed, the food safety team would specify whether the preventive control will be applied at this particular step, yes or no. It is important to note that identifying a hazard at a processing step as one that requires a preventive control does not mean that the hazard must be controlled at that processing step. Check out E.G. Food Company because they answered yes in column 3, which asks, do any potential hazards require preventive controls? They are required to give a response in column 5 and 6. Let's check it out what they do on the next slide. For the pan release oil and the sliced cheddar cheese, the hazard analysis identified undeclared allergens, soy in the oil and milk in the cheese, as significant ingredient-related hazard that will require an allergen preventive control, namely proper labeling of the finished omelet at the pack, weigh, label step. More information will be provided about allergen preventive controls in Chapter 11. For the refrigerated sliced cheddar cheese, the hazard analysis identified 2 additional significant ingredient-related hazards that will require preventive controls. A supply chain preventive control was identified as the preventive measure to control the biological hazard recontamination with environmental pathogens, L. mono, at the cheese supplier level. The supply chain preventive controls will involve verification of the supplier's controls they apply to control the identified hazard in the cheddar cheese before receipt by E.G. Food Company. E.G. Food Company would monitor the incoming refrigerated sliced cheddar cheese upon receipt to assure that it is from an approved supplier whose control has been verified. Therefore, the supplier preventive control would be considered to be applied at the receiving step. More information will be provided about supply chain preventive controls in Chapter 13. For the metal hazard identified in the hazard analysis for the sliced cheddar cheese, a process control was identified in column 5, which will be applied at the subsequent metal detection step at E.G. Food Company. Process preventive controls will be discussed in chapters 8, 9, and 10. The hazard analysis identified salmonella as a significant biological hazard in refrigerated raw shell eggs. Salmonella will be controlled by E.G. Food Company's omelet cook step, a process control applied at a subsequent step. The hazard analysis identified undeclared allergens, egg and shell eggs, milk and wheat, and milk and biscuits, as significant ingredient-related hazards that will require an allergen preventive control, namely, proper labeling of the finished omelet at the pack, weigh, label step. More information will be provided about allergen preventive controls in Chapter 11. The hazard analysis identified 2 additional significant hazards for the frozen biscuits: recontamination with environmental pathogens, Salmonella, which will be controlled by a supply chain preventive control, and metal, which will be controlled by e.g. food companies' metal detection step. At the receiving step, the hazard analysis identified undeclared allergens for the pan release oil, soy from soy, lecithin, sliced cheddar cheese, milk, and raw shell eggs, eggs. It is at the receiving step where these allergenic ingredients are first introduced into the facility. All 3 undeclared allergen hazards will be controlled at e.g. food companies' subsequent pack weigh label step, where the appropriate labels are applied to the finished omelet products, which is allergen control number 2. Note, there is another allergen control number 1 to control undeclared allergens on the incoming packaging to ensure that the labels list the proper allergens, and these finished product labels will be controlled upon receipt by checking the allergen label declarations before labels are used in the facility. This is shown on subsequent slide 14. Allergen control number 1 and number 2 work in conjunction with each other. Food allergen preventive controls will be discussed in Chapter 11. The hazard analysis identified undeclared allergens for the pasteurized milk and frozen biscuit, which has milk and wheat, at the receiving step, since this is where the allergenic ingredients are first introduced to the facility. These undeclared allergen hazards will be controlled by e.g. food company at the subsequent pack, weigh, label step, where the appropriate labels are applied to the finished omelet products, allergen control number 2, and allergen control number 1 at packaging, receiving. The hazard analysis also identified undeclared allergens as a significant hazard for the incoming packaging to ensure that the labels list the proper allergens. The finished product labels will be controlled upon receipt by checking the allergen label declarations before labels are used in the facility. Some companies may decide to check the labels at both receipt and application, or just at application. The hazard analysis identified metal as a significant hazard at the cracking eggs and mix ingredient step, since this hazard was deemed significant due to history with the mixer wire whip breaking. The metal hazard will be controlled at e.g. food companies' subsequent metal detection step. Pathogen survival of a lethal treatment was identified as a significant hazard at the cook step. Pathogens will be controlled by proper cooking at this step. The hazard analysis identified preventive controls for process and facility-related hazards that were determined to be significant at the assembled or wrap step. First, sanitation preventive controls were identified at the assembled or wrap step to control recontamination of the finished omelet products with environmental pathogens, L. mono. 3 sanitation preventive controls will be utilized to prevent environmental pathogen recontamination. 1. Sanitation control. Number 1. Assemble, wrap table, sanitation. 2. Sanitation control number 2. Assemble, wrap, environmental sanitation, floor and the table, support legs. And 3. Sanitation control. 3. Assemble, wrap, hygienic zoning, personnel cross-contamination prevention. Second, sanitation control number 1 is also used to prevent allergen cross-contact from the wheat biscuit. More information will be provided about sanitation preventive controls in Chapter 12. Metal hazards identified in the sliced cheese and biscuit ingredients and at the E.G. company's mixing step will be controlled by the metal detection step. The hazard analysis identified food allergens in the pan release oil, soy from soy lecithin, sliced cheddar cheese, milk, raw shell eggs, egg, pasteurized grade A, milk, and biscuits, wheat and milk, which must be declared on the finished omelet product label. The pack weigh label step is where the appropriate labels will be applied to the finished omelet products to prevent undeclared allergens. Let's do a quick summary of E.G. Food Company's preventive controls identified in the previous hazard analysis slides. Process preventive controls, omelet cook and metal detection, allergen preventive controls. Number 1, label check at receipt, and number 2, labeling of the finished omelet. Sanitation preventive controls. Number 1, assemble wrap table. Sanitation. Number 2, assemble to wrap environmental sanitation. And number 3, assemble to wrap hygienic zoning. Supply chain preventive controls. Refrigerated sliced cheddar cheese and frozen biscuits. To easily develop your food safety plan, information from the hazard analysis can be transferred to the preventive control form, as shown on the slide. This is one way to enable this development, and in the template example forms are found in Appendix 2, pages A2-3 through A2-5. As illustrated in this example, the steps identified as requiring a process preventive control, including CCPs, along with the hazards requiring a preventive control, are transferred from the hazard analysis form to the first and second columns of the process preventive control form. This form may be referred to as a HACCP chart, if desired. The food safety team then lists parameters, values, or critical limits, the minimum or maximum values associated with the parameters, for the controls for each hazard, all elements of monitoring, corrective actions to be taken when deviations from the critical limit occur, verification procedures, and records in subsequent columns. Chapter 9 discusses critical limits, monitoring, and corrective action elements of the process preventive control form. Elements of verification and record-keeping requirements are addressed in separate chapters. A variety of formats can be used to document this information. This course uses the format above, which includes information that must be documented in the food safety plan. Details on information required on food safety plan records are discussed in Chapter 10. Process preventive controls for human food, verification, and record keeping. As a reminder, the types of preventive controls are process preventive controls, food allergen preventive controls, sanitation preventive controls, supply chain preventive controls, and other preventive controls, such as transportation. As a preview of what is to come, this slide outlines what the regulation requires as part of the management components for each preventive control, including monitoring, corrective actions and corrections, and verification. Note that these will be specific to the type of preventive control and how it fits within the food safety system of the facility. More information about the application of preventive controls management components can be found in the FDA Hazard Guide, Chapter 5. This chapter has discussed how to take the information from the hazard analysis and identify preventive controls for those hazards that were determined to be significant. There are 4 types of preventive controls typically considered: process, allergen, sanitation, and supply chain. And the food safety team may also identify other types. Preventive controls must be written and include various management components and record-keeping requirements that will be addressed in subsequent chapters. You have completed the lecture for Chapter 7. Be sure to complete the knowledge check as well as the Chapter 7 exercise. See you in Chapter 8.